Hello everyone, welcome back. In this video, we are going to calculate the required battery capacity for a UPS system step by step. The first step is converting VA to real power in watts using the power factor. For a 3000 VA UPS with a power factor of 0.8, a common engineering rule says we should use only about 70% of the UPS real power continuously. This improves efficiency, thermal performance, and battery backup stability. Now we need to check whether the UPS can handle our loads or not. Our loads are 3 monitors, 1 laptop, and 1 modem. Total power consumption is about 1000 watts. This UPS uses a 48-volt DC battery bank. That means 4 12-volt batteries connected in series. Now, we want this UPS to provide 3 hours of backup time for a 1000-watt load. Battery current is calculated by dividing power by battery voltage. So the battery current becomes To calculate the battery amp-hour capacity, we use the discharge table coefficient. For sealed lead-acid batteries, the 3-hour discharge coefficient is approximately 0.25. Since 83.2 amp-hour batteries are uncommon in the market, we round the value up and select a 100 amp-hour battery. Using larger batteries improves backup time and reduces battery stress under load. UPS efficiency, battery aging, temperature, and inverter losses can reduce actual backup time. Thanks for watching this video. I hope this tutorial helps you better understand UPS battery calculations.